Hello, today I will be covering Passage 3 out of the Science section of the first practice test in the official ACT Prep Guide. Normally, for science sections, I like to just skim over the passage and then go to the questions and see what parts of the passage I need to read in more depth. We'll start by just showing the passage on the left here. Please pause the video and read through it at your own pace. Alright, now we can go on to the first question after having skimmed the passage. The first question, question 14, says, relative to the center of the protostar, does gravity more likely accelerate gas particles inward or outward, and does RP more likely accelerate gas particles inward or outward? So we kind of have four options here. We have the effects of gravity and the effects of RP, and each one of those could go one of two ways, inward or outward. Let's go back to the passage and look at sections where we might find relevant words. Okay, right in the beginning, we have two bulleted points. The protostar's gravitational field attracts gas, causing the gas to accrete, which means accumulate onto the protostar. Alright, that's great. So it looks like gravity attracts gas. So let's see what that means. If we think about gravity and what it does, it's pulling things inward. And so that suggests that H and J are incorrect because they both have gravity as pushing outward. We have F and G as options that show gravity inward. Now we need to evaluate what RP does. Radiation pressure, or RP, is associated with the protostar's emissions, and it causes gas to be pushed away from the protostar. So if the protostar is having some gas in the center, and then it's getting pushed away, that means that RP is pushing that gas outward. This means that the correct answer is G, because it has gravity pulling the gas inwards and RP pushing the gas outwards. Going on to the next question, question 15, it reads, based on scientist 2's argument, do gas particles more likely accrete near the equator or near the poles of a protostar with a disk? Okay, so let's think about what this means. It's asking about the gas particles and where they accrete. Is it near the equator or near the poles? Let's go to scientist 2's paragraph here. Okay, the second sentence looks relevant. However, because a protostar rotates about its axis, a disk of gas forms in the plane of the protostar's equator. Okay, a disk of gas in the plane of the protostar's equator. Okay, so let's go back to the answers. And that suggests that it's either A or B, not C or D. Because we know that gas is in the plane of the equator, and C and D deal with the poles. Let's go and read the effects of RP. And the third sentence says, this reduces the effect of RP in that plane, allowing gas from the disk to readily accrete. Okay, so we know that the gas is near the equator, and the effects of RP are reduced. So let's go back to the options. We have A and B both near the equator, and then A is because the effect of RP is increased there, and B is the effect of RP is reduced there. And we know from the third sentence, this reduces the effect of RP, that B is the correct answer. Next up, we have question 16, which asks, detailed surveys of star clusters in and near the Milky Way have yielded no evidence of stellar mergers having occurred at any time during the galaxy's history. These results are inconsistent with the arguments of which scientists? Now, something that occurs throughout the ACT and SAT tests are highlighted or italicized or bolded words. The ACT doesn't want you to fail, and in fact they don't want to trick you. So here they highlighted the important word, inconsistent. So we're looking for viewpoints presented by the three scientists that go against this previous sentence. We'll have to revisit the options over here in the scientists' paragraphs by reading about what they say about stellar mergers. Scientist 1 says, let's see, the last sentence looks pretty good here. Stellar mergers are likely. Alright, so it seems like Scientist 1 supports the idea that stellar mergers have occurred, and that goes against this sentence here. Let's go on to Scientist 2 and see what they have to say. Wow, right off the bat they say that stellar mergers are likely, and that's in line with Scientist 1. So it looks like Scientists 1 and 2 disagree with this sentence here. Going on to 3, the first sentence says stellar mergers are very unlikely. Based on these three paragraphs, it looks like 1 and 2 think that stellar mergers are likely, and 3 thinks they are unlikely. Given that the sentence is asking, have they occurred, we can think that, okay, let's see what the options are here. F, Scientist 1 only, no, because 1 and 2 are in the same page. And then G, Scientist 3 only. Well, Scientist 3 agrees with this statement. this statement is consistent with scientist 3. It's not inconsistent, and the question is asking for which ones are inconsistent. Therefore, we know that H is the correct answer because what scientists 1 and 2 say goes against the sentence in question 16. Moving on to question 17, it says, one of the most massive stars known is Eta Carinae, which has an approximate mass of 120 solar masses. Based on the arguments of scientists 1, 2, and 3 respectively, what is the minimum number of stars, each formed entirely by accretion, that would have been required to form Eta Carinae? Okay, so this question is asking, how many stars formed entirely by accretion can come together via a stellar merger to produce a star that is 120 solar masses? Okay, and we're going to have to read what the 3 scientists say. So going back here to scientist 1, the second sentence is relevant here. As a result, the maximum mass that a protostar can reach by accretion is 20 solar masses. Okay, so if we had 6 stars at the max level, so 20 solar masses each, and there are 6 of them, we would have 120 solar masses, which is the amount needed to get a star as big as Eta Carinae. So based on what scientist 1 says, that 20 is the max, we know that A and B are not correct, and C and D may be correct. We need to go on to what scientists 2 and 3 say. Going to what scientist 2 says, we see that the maximum mass that a protostar can reach by accretion is 40 solar masses. Okay, so based on this, we can look at 120 solar masses, divide it by 40, and we get 3 as the minimum number of stars of that size necessary. So going over to here, we know that C and D may be right, and only C has scientist 2 saying that they need 3 stars as the minimum. Because of this, we know that C is the correct answer. Note that we never even had to see what scientist 3 said, because scientist 1, looking at that, narrowed it down to C and D, and what scientist 2 said narrowed it down to just C. So this is kind of a theme throughout the ACT, is only read what you need to read to answer the question, and then move on. Next up is question 18, which says, when the effect of RP overcomes that of gravity, a star is said to have emerged from its envelope, because that is the first time the star is directly observable from outside the cloud. An observation of which of the following stars emerging from its envelope would support scientist 2's argument, but weaken scientist 1's argument. Okay, so let's unpack what this question is asking. We introduced a new phrase here, emerged from its envelope. What does that mean in this case? In this case, it means that there is a star that is still gaining mass, and it's in the accretion disk, and it's not reached its maximum limit. So what are the main differences between scientist 2 and scientist 1? What does scientist 2 say that would be supported by something that would weaken scientist 1's argument? We scroll back up here. Scientist 1 says that the maximum mass that a protostar can reach is 20 solar masses, whereas remember scientist 2 said that the maximum mass is 40 solar masses. So if there is a star that was forming in between those ranges that was bigger than the maximum mass that scientist 1 said, but smaller than the maximum mass that scientist 2 said, then it would support what scientist 2's claim that stars can get up to that size, and it would debunk scientist 1's claim that the maximum size is 20 solar masses. So we're probably looking for a star between 20 and 40 solar masses. Scrolling down to question 18 and looking at the possible answers, we see that F and G are both within the realm of possibility for both scientists 1 and 2. J is outside the realm of both of them, but H is right in between. So H is the correct answer here, because it supports scientist 2 argument, but weakens scientist 1 argument, because scientist 1 said that 20 solar masses is the maximum size for a star. Next up is question 19. It says, scientists 2 and 3 agree that a disk forms around a protostar as a result of the protostars. Then we have a few options here. So let's go see what scientists 2 and 3 say about how a disk forms around a protostar. Scientist 2 says, however, because a protostar rotates about its axis, a disk of gas forms in the plane of the protostar's equator. So let's see, a disk of gas forms because a protostar rotates about its axis. Okay, so that's relevant for us here. Let's see what scientist 3 has to say. Scientist 2 is correct about the formation and the effect of the disk. Alright, so scientist 3 is just agreeing with what scientist 2 says here. So the important part is that a protostar rotates about its axis. Let's go down and look at the possible options for question 19. As a result of the protostar's motion, emission of radiation, location within a star cluster, or merger with another star. Okay, so neither of them really mention radiation or location within a star cluster. They do mention merger with another star, but that's not about how the gas disk forms. We scroll back up and look at scientist 2, and what we highlighted, a protostar rotates about its axis. That's a motion, and therefore the correct answer is A for question 19. The final question for this passage, question 20, says, which of the scientists, if any, would be likely to agree that the Sun could have formed entirely by accretion? One of the options involves all three scientists, so we need to read passages from all three scientists. Let's scroll up and see what this means. So we're trying to figure out if the Sun could form by accretion. Scientist 1 says, the maximum mass that a protostar can reach by accretion is 20 solar masses, and of course the solar mass is equal to the mass of the Sun, so it seems Scientist 1 supports the idea that the Sun could be produced by accretion. Let's see what Scientist 2 says. The maximum mass that a protostar can reach by accretion is 40 solar masses, again well within the realm of the Sun, which is just one solar mass. Scientist 3 says, the maximum mass that a protostar can reach by accretion is limited only by the amount of available gas. So, the solar mass that Scientist 3 claims is unlimited. So based on this, it seems that all three scientists support the idea that the Sun could have formed by accretion. We scroll down and we see that option H, scientists 1, 2, and 3, is the correct answer. Okay, so let's recap some of what we learned through this passage. One re-emerging theme was that there were very small pockets of the passage that were very important for multiple questions. The maximum mass that a protostar can reach from Scientist 1 and Scientist 2 was used in multiple questions, and for Scientist 3 the maximum mass was used in at least the last question. Additionally, we noticed that the words that are important in the questions are often italicized or bolded. In this case, inconsistent and minimum were already italicized for us. Note that the ACT wants you to succeed. They don't want to trick you, and they want to help you understand the question well. So that's it for this passage. Thank you for watching.